taking the time today to view this presentation. My name is Sean Koda, and I'll be walking you through a project titled Quote Conversion AI Copilot, Predicting Quote Conversion Rates. This project is going to focus on how we can apply machine learning to help sales teams make smarter, faster quoting decisions, ultimately improving conversion rates, protecting margins, and driving revenue growth. Over the next few minutes, I'll take you through the full life cycle of this product, from the problem definition and business understanding to the model design, validation approach, and production risks. And I'll show you how we turned a business challenge into a data-driven solution. Opportunity evaluation. In B2B sales environments, reps often have to guess which quotes are likely to convert into a real order. And too often, quotes will either stall or they will fail to close entirely, which means missed revenue opportunities and wasted effort. And when sales reps try to compensate by offering deep discounts, margins can take a hit as a result. And so that's the core problem. Too much manual judgment, too little data-driven guidance. Machine learning can change that. Even a small lift, let's say a 3 to 5% improvement in quote-to-order conversions, can drive millions of dollars in additional revenue for organizations. The good news is organizations already have the right data: historical quotes, outcomes, buyer information, pricing, SKUs, all the labeled data needed to train a predictive model. And since these quoting systems run inside CRMs or ERP platforms, it's straightforward to test the model with clean A/B experiments and to measure the business impact directly. In this project, our goal is to predict whether a sales quote will convert into an order within 14 days. This problem directly impacts our sales representatives because quoting today is still largely a manual process, with reps entering and tracking inside CRM systems without any predictive support. By introducing a model, we can help them prioritize which quotes to focus on and respond faster to high probability opportunities. Success will be measured in both business and technical terms. So on the business side, we're looking to lift our quote to order rate, improve gross margin dollars, and shorten the overall sales cycle time. And on the technical side, we're going to monitor model performance through metrics like AUROC, calibration error, uplift versus our baseline, and prediction latency. This will help us ensure the system is accurate, well calibrated, and responsive enough for real-time use. The key factors we're going to evaluate include the quote price and discount, the quote volume, buyer history, product bundles, and external market signals. Together, these features should give us a clear picture of which quotes are most likely to close quickly and which ones may need more attention or adjustment. So our solution concept is an AI-powered quoting engine that recommends optimal discounts and pricing for sales reps. Essentially a conversion model that predicts the probability that a quote will close. To validate the solution, we're going to take an iterative, low-risk approach that builds trust and measures impact at each stage. So we'll start with the prototype phase, using static mock-ups or sample recommendations to allow us to collect user feedback and gauge trust. Do these recommendations feel realistic, and are they helpful to the sales reps? Next, we'll move into shadow testing. This is where our model will run silently on live quotes in the background. During this phase, reps won't see any of the predictions, but we'll compare the model's outputs against the rep's actual actions and measure alignment and accuracy. Once the model is performing well, we'll conduct a limited A/B pilot. A control group will continue using the traditional quoting process, while a treatment group will use the model-assisted recommendations. And we'll measure quote-to-order conversion rates, margin performance, and adoption levels. Finally, after validating the results, we'll execute a gradual rollout across all regions. This will certainly include applying business guardrails, such as discount limits, and running weekly calibration checks to monitor drift, performance, and user adoption. For our machine learning system design, we made 3 key decisions. First, We chose a cloud deployment to ensure scalability and unified access to the data needed for training and predictions. This approach makes it easier to integrate within existing CRM and ERP systems while still maintaining strong governance, version control, and auditability. Secondly, we'll use a hybrid learning approach. The model is trained offline in weekly batch retrains. This gives us stability, reproducibility, and controlled updates, while we apply daily online calibrations to stay responsive to market and pricing shifts. This balance ensures faster quoting, higher conversion rates, and steadier margins over time. And finally, we serve a real-time online prediction model with response times under 300 milliseconds. That means sales reps are getting instant data-driven recommendations right inside their quoting workflow without any noticeable delay. Together, these design choices make the system scalable, responsive, and business safe, ready for production use in any sort of live sales environment. As with any machine learning system, there's going to be several risks we need to anticipate and manage once the model goes into production. The first is training serving skew, when the features used during training don't perfectly match what's available in real time. We mitigate this through a centralized feature store and automated schema validation tests to ensure consistency. The second is data or concept drift, where the underlying business dynamics change over time. For example, new products, seasonal patterns, or pricing behaviors. To handle this, we use drift monitors and rolling retrains that keep the model up to date. Next, we address bias and fairness. We closely monitor model outcomes by region and customer segment to make sure recommendations remain consistent and equitable across markets. On the system side, we manage latency and reliability with auto-scaling, circuit breakers, and fallback heuristics, ensuring predictions remain fast and dependable even under high load. There's also an adoption risk. Sales reps need to trust and understand the model. We mitigate this through clear explanation and interactive what-if sliders so reps can see how different inputs affect the recommendation. Finally, we guard against over-discounting by enforcing business guardrails and optimizing for a blended win margin objective, balancing conversion rate with profitability. Together, these safeguards ensure the system is robust, compliant, and trusted by its users, not just accurate in theory, but effective in real-world production. In summary, the Quote Conversion AI Copilot could potentially bring intelligence directly into the quoting process, turning what was once a manual, intuition-based workflow into a very data-driven system that helps reps focus on the right opportunities. By combining explainable AI, thoughtful validation, and strong governance, we've built a solution that's not only accurate, but also trusted, compliant, and scalable. Thank you for your time. I hope you have a wonderful day.